Good morning, class. So, in this live lesson recording, we're going to be going over Unit 7, Lesson 6 notes, which is all about the volume of cones. And if you watch the Lesson 5 notes, we talked about the volume of cylinders. And in that lesson, we had basically the exact same formula for the volume of cones and the volume of cylinders. The only difference is in the volume of cones, we have this 1/3 in front. Okay, that's the only difference. Everything else was the same. So it's pi r squared h. So that part of it was exactly the same. The only difference is this 1/3 that's out in front. So that was this lesson right here, volume of cylinders. So like I mentioned, exact same formula. The only difference is the 1/3 that's out front. Okay. So with that being said, the one thing that you really want to pay very close attention to when you're doing these volume formulas is whether it's giving you the diameter or the radius. So what we want is the radius. So we only want half the diameter. So if it gives you the diameter, remember to only use half of that because we want the radius, not the diameter. Okay. So volume of a cone with a diameter of 20 centimeters and height 15 centimeters. So the formula again is volume equals 1/3 times pi r squared times the height. So r, of course, is the radius, h is the height. So you can see that here. Here's the radius, here's the height. Now this is the slant height, but we don't need that for the volume of a cone. That's unnecessary. We don't need it. We only need the height and the radius. Okay, so the slant height is used for surface area. So if you remember back to the lesson on surface area, that's right here, surface area of cones. You'll use the slant height for that, but not for volume. Okay, so back to this one. So we're going to do 1/3 times pi. So for pi, we're going to use 3.14 every time. Times the radius squared. So in this case, the diameter is 20, so the radius would be 10. So 10 squared is 100. But I'm just going to plug it into Desmos. I'm just going to put these numbers in parentheses. Times, and then the height is 15. All right, so that's going to be equal to, okay, so what I'm going to do is I'm going to plug the formula in once and just reuse it over and over and over because it's the same formula every time. So I'm going to do 1/3 arrow over times 3.14 times 10 squared. So this is our square times the height, which was 15. So this is the 1/3. This is pi. This is the radius. The radius was 10. And then this is the height. So now all we have to change is the radius. Oops, not the squared part. The radius and the height each time. And I'm just going to keep using this formula. So the answer is 1,570. So the volume of this cone is 1,570, and in this case, it is centimeters cubed or cubic centimeters. And again, volume is always in units cubed because it's three-dimensional. So there's length, there's height, and there's width to volume. Whereas area is only two-dimensional. Okay, so this one's one of those weird ones. It's an oblique cylinder, or not cylinder, oblique cone. So the height that we care about is the height from the bottom to the top of the cone. That's all that matters. So it's telling us here that it's 9. And again, that formula, and again, you don't even have to, like I'm about to rewrite the whole formula, but you don't need to do that because all you have to do is go into Desmos and change the numbers. So all you care about is the radius. So this time it gives us the radius, not the diameter, and the height. Okay, so the formula again is volume is equal to 1/3 times pi. So again, we're using 3.14 times the radius squared. So that's 5 squared times the height. All right, so for this one, all I need to remember is that the radius is 5, the height is 10. Or sorry, 9. Oh, too early of a morning, I guess. All right, so I'm going to go in here and I'm going to change the radius to 5 and the height to 9. And again, that's the nice thing about Desmos is it just saves the formula and you can just keep using it over and over. So 235.5 is our answer. And in this case it is cubic inches, or inches cubed. And that is it for that one. All right, number 3, it says a professional baker uses a chocolate mold to make decorations for cakes. It's kind of funny. I've just been watching a show called Is It Cake? If you guys have ever watched that on Netflix, where people try to like make real life items, or make cake look like real life items. But anyways, moving on. So one chocolate mold is in the shape of a cone and has a diameter of 4, height of 8, whereas the volume of chocolate in cubic centimeters is needed to make the solid chocolate cone. Okay, so again, it gives us diameter, so we don't care about the diameter. We want the radius, so the radius is half of that, so 2. Okay, and I'm gonna rewrite the formula. You don't have to do this every time. So the formula is 1/3 times pi times the radius squared, so that's 2 squared, times the height, which is 8. So again, the only numbers that we need to change in Desmos are the 2 for the radius and 8 for the height. So we're going to go in here, change the radius part of the equation to 2 and the height to 8. And this one we're going to have to round because you can see that has all that at the end. So we're going to do 33 point, you can either do 0.5 or 0.49. We'll go with 0.5, 33.5. Does it say where to round? Nope. So we're going to round it to, it's approximately 33.5, and in this case it was centimeters, so cubic centimeters. Seems like a decent amount of chocolate, although not really now that I think about it, because the radius of the chocolate is only 2 centimeters. So if it's 4 centimeters, that would be like, the diameter is 4 centimeters, so it's only going to be like that wide. Not a very big cone. Okay, question number 4. It says the sandcastle mold is in the shape of a cone with a diameter of 3 meters. Again, we want the radius, so we're going to do half of that. So radius is 1.5, because half of 3 is 1.5, and then a height of 5. Okay, so once again, I'm going to keep saying this. You do not have to rewrite this equation every time. You can just change the radius and the height in Desmos, but I'm just going to write out the equation each time just to kind of show you all the steps. So 1/3 times 3.14 times the radius squared, so 1.5 squared, times the height, which is 5. Okay, and again, the only numbers that we care about are the radius and the height, so 1.5 and 5. So I'm going to go in here and change this to a 1.5 and change the height part of the equation to a 5. And we get 11 point, we'll just say 11.8. We'll round it to 11.8. We'll round it to the nearest tenth. It doesn't tell us where, so approximately 11.8, and in this case it was meters, so cubic meters. All right, and the last one that we're going to do, again, same thing. Vase is in the shape of a cone, radius 6, height 17. What is the volume of water it can hold? Okay, so we're going to do 1/3 times pi times the radius squared, so that's 6 squared, times the height. And again, we only care about the 6 and the 17. The radius and the height, everything else is the same. So the radius was 6, and the height was 17. So we'll round it again to 0.6. So 640 point, and then this will round up to a 6 because the number after it is above 5. I already forgot the number. 640.6. So that would be 640.6 cubic centimeters. That is it for that question. All right, guys, that is it for lesson 6. When we get to lessons 7 and 8, we're going to be talking about spheres. So a ball is essentially what a sphere is. When we think of a sphere, we think of a ball. So like a basketball or a soccer ball, those are all spheres, or a beach ball or whatever. Okay, so we're going to do the surface area in lesson 7, volume in lesson 8. When we get to lesson 9, we're going to talk about how do you compare cones, cylinders, and spheres with the same height and radius. So that's kind of an interesting lesson. And then after that is the test, because we dropped the sample work. Well, there is practice test too, but then the test. All right, guys, we will see you in the next live lesson recording. Have a fantastic rest of your day. And if you need anything, again, you can always reach out and book some time with me. Have a great rest of your day.